Hi everyone, welcome back, and let's discuss another problem from our binary trees. Give me a second. I'll just connect the mic. Let me check if we are live, guys. Yes, we are. Okay, let me show you the problem statement for today. So this is going to be convert a given binary tree to doubly linked list. Okay, so this is going to be our problem for today. Let's understand what we have to do. I don't know why it has been placed as a hard question, which it is not. Okay, so given a binary tree, convert it to a doubly linked list in place. That means you have to create two links. One is the forward one, other one is the backward one. Okay, we will code it in place. The left, you're not allowed to take any extra space here. Other thing is, first let me complete the question. The left and right pointers are used as previous and the next pointers. Okay, you can treat the left pointer as the previous pointer and the right pointer as the next pointer of a linked list. Okay, the order of nodes in DLL must be same as in order of the given binary tree. So let me take this example and then I will explain what we have to actually do in this question. You'll understand it very easily, quickly. So see, this is for example a tree 10, 12, 15, 25, then we have 30, and then we have 36. First of all, tell me what will be the in order traversal of this binary tree. So in order traversal means you first go to the left part, then you write the root, and then you print the right part. Okay, this is your in order traversal. So in this case, root, then you go to its left, then you go its left, and then there is null. So this, then you go to the right part. So root part, first of all I will print 25, then you go to its root, which is 12, you print it, then you go to its right part, which is 30, and there is no left, all are null, so you'll print 30. You'll come back, print the root value, which is 10, and then you go and explore the right subtree of 10, which is 15, but you will not print 15 because you are still exploring the left part of this subtree. So you go to 36, you print 36 as this is the left of this 15, then you print the root itself, which is 15, then there is no right to the node 15, which is null. So you go back and traverse and you see that you have printed the entire, all the nodes of this list, of this binary tree. Now in this traversal, the order in which we are getting the nodes, you just have to create the links between them. One will be the forward link. So in linked list, generally when we create a class node, or we have that already by the compiler, we have a next pointer and we have a previous pointer for a doubly linked list. So here we already have a class node of a binary tree, which will have your left pointer and your right pointer. So we can utilize these already present pointers, node pointers, as your next pointer will be your right and the left one will be your previous pointer, will be behaving as your previous pointer. So these are the links that you have to create. So 12's right should be 30, 30's left should be 12, 30's right should be 10, 10's left should be 30, so on and so forth. So finally what you have to return to the function is the head node, and it will take care how to print it. Let's see what is the answer. We got 25, 12, 30, 10, 25, 12, 30, 10, 36 and 15. Right, that's what we had, 36 and 15. So this is how you have to create the links. So we are going to come back to our recursion. We are going to, how do we do the in order traversal? Similarly that thing. So what do we do in an in order traversal? You do some things. First of all is your base case condition. What is going to be your base case condition? So let me write DLL. Okay, BT, this is your function, func f. Let me create it nicely so that you can understand. So for example, we have a function here by the name of DLL, for example. Okay, this is your function name DLL. Now you have some root node, right? Node root is there. What I'm going to do is, let's create, I want to finally return the head node of this linked list, this doubly linked list, and my traversal order would be in order traversal. Let me create two nodes, node previous, which is also null initially, and node head, which is also null. So basically I have to return my head node, and previous will act as my iterator of this linked list, which will be used to create the links between the nodes that I am processing in my recursion function. So DLL is the function name. Let me write the pseudocode here. So what will be your base case condition? If you have a null node, if root is null, okay, you just simply return. Let us make this a void type function. I just have to update my head node, and that is what I have to finally return. So let's make it in a function. In the given compiler, you are given to complete this particular function whose return type is node, where we will be actually returning the head. So let's make it a helper function. This DLL will act as your helper function, which will be of type void. Its only task will be to update the right head and create a linked list, doubly linked list like this. Okay, so when your root is null, you just simply return from there. Then what you have to do, you pass this tree for the left subtree. Okay, you make a call to the left side of this tree, which will be your root.left. Okay, so it goes and recursively calls until you get a null from the left hand side. Then what you have to do is you have to make some decision when you are at the root node. That is how you process in an in order traversal. Now you have to make some decisions when you are present at the root node level. Okay, when you are at the root node, what you have to do, that is when you have to first check if your previous is null, previous node is still null. Okay, that means I have not yet found the head node of my linked list. So if I am currently at any particular node, let's say when I will be at 25, I know that will be the beginning of my doubly linked list, and my previous is still null. So in that case, this simply tells me that my head should be pointing to root node. This is one thing. If not, if let's say then you will make your previous point to this head node. But if that is not the case, for example, previous is already at 25, we'll do the dry run, don't worry, you will understand it. But if previous, for example, is already at 25 and you are processing this thing for 12, so you have to make sure that you create two links like this, which will go in the else case, and that will be that previous dot right should point to which node? Previous dot right should point to this current node, which will be a root node. Okay, and then your roots left should also point to previous node. Root, we have to form the link both ways. Root dot left should be pointing to your previous node. This thing should go into your else case, and for both if and else, regardless of whichever condition we get into, we have to make sure that previous simultaneously moves. Previous is acting as an iterator of this doubly linked list, so I have to make sure that previous takes its position as the current node at which we are present. So previous should be pointing to root node. This is what you have done. This is the processing for the root part of your node, right, where you are creating the links, forward link and the backward link using right and left pointers, and then you have to repeat the same process for the right side of your linked list, right side of your tree, by making a call to root dot right. Let's do a dry run and you will understand. So this is about the recursion, the function, and which is very simple. Actually, the root is this entire code is going to be very simple, which you can just see here. Let's make this iteration. Let's do this iteration on some tree. Let's take the same tree and we will do an iteration. So what we have is 10, 12, 15, 25, 30, 36. Let's understand. So you make a call with passing of the root node. Right now I will keep updating my head and previous here. Head is also null and previous is also null right now. Okay, you make a call for 10, you check your root is null. No, it's not. So you make a call to root dot left. So right now in your recursion stack, what do you have? You made a call for 10. Now you have a call for 12. Then you check again, root is not null. So you go and process its left side. Let me write it properly so that you can understand. This is the recursive stack I'm creating for you to have a better understanding on the linked list, in case you do not have yet, which I do not expect. If we have solved so many questions on trees and obviously of recursion, then you should be clear with this. But anyways, okay, first I made a call to 10, then I made a call for function by passing 12, then I made a call to the function by passing 25 via this line. I have not advanced after this line. As in when I come at this line, I go and make a call to root dot left. Now when I make a call to 25 is left, which is null here, so I return, and then return will go to the next line of the statement to which it returns. Then I come here, I remove this from the call stack, okay. Then I make some decision, okay. Right now you have removed 25 from your call stack. Then you check, okay. You know that currently your root is still 25. You check if your previous is null. Yes, my previous is null. So one thing that I have done is that first of all, my head right now is pointing to 25. So this becomes 25, okay. Fine. If previous is null, your head node, this head node becomes 25, and you come out of, then you come and execute this line, which makes your previous also point to root, which is your head node. So basically previous and head right now are at 25. This is your list. This is the node that I have created, and this is my head node. Then you make a call for root dot right, which is 25's right, which is null again. You go and finally come at this when you were making call for 12 left, which has been returned now. Again you come to this line, you check is your previous null right now. No, previous is not null. So you go to the else part, execute it, and previous dot right should be pointing to root. What is your root right now? It's 12. I am doing this for now. I am checking, basically I have from my call stack, this 12 will remove after I process all of these things. What am I processing? That 25 is next should point to 12, and 12's left, root dot left, should point to previous, which is 25, correct. So this link has been created, and from this line your previous has moved to 12 right now. So previous is pointing to 12 right now, correct. Okay, then you make a call to the right of 12, which is 30. So in my stack now I have 30. Now I process it for 30. Root is null? No, root is not null. Then you make a call to root dot left, which is null obviously, and then you do the things for 30, which will be actually, if your previous is not null, you go to the else part. So previous is 12. 12 will be pointing to 30. 30 is next, left will be pointing to 12, and your previous will move to 30. Okay, right now this is 30, and 30 will be removed from the call stack. Now you will repeat the process for the right part of 10 by making a call to function of 15. Okay, you are making a call to 15 and repeating the same process. Now this link will be created for 15. But wait, when I am at 15, I will make a call to root dot left. Now what will be at the top of my stack? 30, when I made a call to the function by passing root dot left. So 36, sorry, whatever it is, 36 it is, right? So 36 is at the top of my stack function with the function call when I have passed 36 as my root. So I process for 36. So the next link that I will create is actually 30 10. I missed one node here. That was when I was doing it for 10, and then I moved to its right part. Okay, now the next link that I will be creating would be 36, and 36 left will be 10, and this will be removed from the stack, and then I must be processing it for 15. That's how it is. Okay, so I hope you understood, and simultaneously your previous is pointing here finally, and you will come out of all the calls will be removed from the call stack. That's how finally what is present in the head, 25, that will be returned to your function. So I think you have understood. In case you have any doubts, you can ask me. That was all about it. Okay, so let me write the code for you guys. Have a look. So let's create one. As I told you, we'll create a new void type function. So before that we will create two instances. One will be node head, other will be node previous. Okay, I will be declaring it in my class outside the function. Otherwise, whatever values I give, it will not be reflected when I will try to return to this function. Okay, so void helper node root. If root is null, just return. Okay, and then you make a call to helper function by passing root dot left. Then you take some decisions. If previous is equal to null, that means your head should be pointing to root. In the else case, you create links by making previous dot right pointing to root, root dot left pointing to previous, and this is your else. And in both the cases you have to make your previous point to the root node, whichever current node you are at, and then you repeat the same process for root dot right. Okay, fine. So that is about this function particularly. helper, you making call to root dot left, previous is null, then your head is pointing to root. Fine, this is your if case, this is your else case, then you come and make a recursion. In your this function, I will just here I created the instances, here I will initialize my instances. My head is null, my prev is null, and I am making a call to helper function by passing root in it, and finally what do I have to return to my function is the head node, right? So that's about it. Let's compile. It's a simple question only. See, if your concepts of recursion are clear, see how simple it was. I don't know why they have tagged it as hard, and that too for 8 points. So well and good if you are able to do it yourself. That's all, everyone. Finally done. One more question to go for binary trees, which we will take tomorrow, and your binary trees topic will be done. So that was all for today, everyone. Let me know if you have any doubts. If not, we will wrap it up. Okay. Fine then. Thank you and take care, everyone.